Already got questions. Hello. Hope you're all well. As a reminder, in case anybody is new here, um, the first part of the thing that I do for about until about 8 o'clock is mainly for anybody in year seven, eight, or nine. So you will have from homework either a booklet one, a booklet two, or a booklet three, and you can, if you want, ask some questions from any of them. If not, I might just pick out a few questions at random and just go through them. This topic that you did at the weekend is really important to be good at because it affects all of your maths and possibly some of your science as well, if you are able to rearrange some equations. And then from 8 o'clock, I'll do the same thing for those of you in year 10 and 11 who had some other maths topics, or year 10 had the same, but a harder version of it. Anybody got any questions firstly from any of the homeworks? Yeah. If not, I'm just going to actually pick out some from each one. So, question 32, year 9. Okay, we'll start with that. 32? Oh, yeah, it's because it was one of these. Okay, I will start with that just because someone has asked it. We have to, in these questions, make X the subject, which means that we have to get X by itself. So these questions uh, can have numbers in, or they could not have numbers in. Um, these ones obviously don't have any numbers, it's all just letters, which does make it a little bit harder, but it is important to be able to do this. This is why we give you these type of questions often at this stage, because it is important to be able to do it without some numbers. So, question 32, which says y minus x squared, no, y minus x equals y squared. Okay. So if you want to make X the subject, that means get the X by itself on one side. Now, whenever the thing that you're trying to make the subject is a minus, as is the case here, it is usually easiest or important to move it to the other side, because when you move it to the other side, it will become a plus, right? You add a negative number to the other side. So I'm going to do that. So on this side, I will still have this y squared, but this minus x becomes a plus x. And on the other side, I've still got this y. So I leave that there. And then all I'm going to do is move all of this y squared to this side by taking it away, because it's a positive when there's nothing in front of it. So y take away y squared equals x is enough for the answer to that question. You could do a little bit more, but if the question says make x the subject, then you should just stop when you've made x the subject. You've got it by itself, and so there's no need to do anymore. Um, and yeah, that's all I would do for question 32. One, yeah, 9, y minus x equals y squared. Um, yeah, that's it. Any other questions from that one? Let me see if I can pick anything out. I might just do question 40 while I'm waiting. So this one here says h m take away x equals n. Whenever you have brackets, well, no, not whenever, but most of the time when you have brackets, you tend to um, I'll do question 39. In fact, no, I'll do question 39 now. Most of the time when you have brackets, you will usually expand them out. You don't have to, but you usually do. So I'm going to do that because that is the most common thing that people will do. So to expand these brackets, you do this times this. And when you times two letters together, you just stick them together like that. And then you times this by this. And again, you stick the two letters together, but remember, this is a minus over here. So it's minus, and then we'll call it AX equals C. Okay. Then this becomes kind of like the question I did before, where because this thing that I'm trying to make X the subject, right? But right now it's a minus because it's got a minus attached to the front of it. I'm going to move all of this to the other side. Okay, so on the other side, I still have my C, but this minus AX has become plus AX. And then on this side, I've still got this AB. Okay, so then what I'm going to do to get this x on its own, I'm going to move this c to this side. So it becomes AB take away c equals, and then I've still got this ax on the other side. So that's there. And then finally, to make x the subject, I just need to get rid of this a from near it. Because this a is being timesed by this x, I will have to do the opposite when I move it to the other side, which is divide it. And when we just do a big line and put the a on the bottom. And that would be the correct answer. There are other ways to do that, but that is correct. And that's question 39. Year 9. Um, There is just a reminder, in case anybody again is new, there is a on Zoom a Q&A option. That's where you need to go on to type a question to me. The chat won't work. Okay, while I'm waiting, I will just have a look at some of these questions, which is what the students in year 8, these are, yeah. What does it mean when there is a plus and a minus underneath or on a square root? Is that, you're looking at the answers, aren't you? Right. So, first of all, I will just wait for one more thing. I think I said this last week, but I decided to leave it, which is, as it stands, all of the homework that you have had so far this month, those codes that are at the back of it worked while you had it, partly because I just wanted you to experience what it is like. However, as of next week, they will not work until you have had the homework back mark, just so you know. Um, oh, it was on your notes. Oh, apologies. Anyway, it is in the answers as well. I understand the x over 3 question. I need you to be more precise about what you mean. If you tell me the booklet number and the question number, then I will know what you mean by is this x over 3 question? Oh, right, okay, found it. Let me do that first, then I'll answer the square root thing. So this question here says x over 3 plus 1 equals 5. Okay, what we need to do is make x the subject, or get the x by itself. That's what we need to do. Okay, but there's numbers here, so we'll have an actual number at the end as the answer. Whenever you have something being added or minus to a whole thing, you should start with that and move it to the other side. So that plus one will move to the other side and become a minus one, leaving you with just this x over 3 on this side. Then, if you can work out what this is, you should. 5 take away 1 is 4. And if you notice how I'm doing my working out, this is really important. Your working out should kind of always go like this, downwards like this. And then to finish off, if I want to get this x by itself, and right now it's being divided by 3, I can remove the 3 by timesing it to the other side. And therefore you get 12, and x is 12 in this particular case. More questions. Yeah, x over 3 plus 1 equals 5. Yeah, that's that. So the QR codes are definitely the answers. They are there. Most of them have a video, but the videos aren't all ready yet, so they might not always work. But you will have the answers if you scan the QR code, and then usually what it does usually is it opens up the questions, but then the answers are at the back. So if you scroll down, you'll get to the answers. But as I said, those are only going to work after this week. They will only work after you have done the homework and had it back marked. It is not meant to be used, obviously, to do the homework, but I left them active for now so that you could get the hang of how it works. For the rest of the year, you will hand in the homework. You won't be able to have the answers available to you. You will then, but you'll still come here and ask me. So that's the same thing, I suppose. But yes, those QR codes have the answers, but they won't work until after you have had it back marked from now on. Okay, the plus or minus thing. Let me just briefly explain that. So if I said to you this question, x squared equals 9, let's just say, if I gave you that question, then the way you answer this question is to get the x by itself, you square root the 9. Now, what does square root mean? Square rooting a number means that we're trying to find a number that when you times it by itself, you get the answer inside the square root. So hopefully all of you know your times tables and therefore know that the number that times is by itself to make 9 is 3. So 3 would look like the answer to this question. But I'm going to ask you another question now. Is there any other number that when you times it by itself, the answer is 9? Does anybody know or can write any other number that when you times it by itself, the answer is 9? Not 3, I need a different number. -3 is correct, because if you do -3 times -3, the answer is still 9. So if I said to you, what is the square root of 9? And I'm asking you, what number times is by itself to give me 9? There's actually two answers to that question. There's 3, but there's also -3, which is why sometimes you will see something like this written down there to show that there's two answers, or you can actually write it there to show that even when you square root any number, there are two answers to the question. The square root of 16 is actually plus or -4, because -4 times -4 also gives you 16. So that's what that plus or minus means, as somebody has asked me. It means that the answer, so yeah, on a square, you have it only on square roots, because when you square root a number, there are actually two answers, the positive version and the minus version to it. Any other questions? Somebody is raising their hand, but I presume that's just because there's an option to raise your hand as opposed to anything else. Could we write it as the negative square root of the number, like a negative is before the square root sign? Yes. So, well, yeah, as long as you put it before the square root sign, you're fine. So normally that's just what we do. So if I said to you x squared equals 11, for example, then x would be the square root of 11, but you'd put the plus or minus there. That's what you'd normally, you wouldn't normally just put the negative, because that's not true either. It's both, right? It can be the positive version or the negative version. So you normally put both of them. Right, just while I'm waiting, I'm going to pick out another question from here. I mean, hopefully these are all these ones that weirdly in the booklet too, the students in year 8 had are actually easier than the year 7s and year 9s had, because there's a reason for that. But if I was answering this question, 7y add 2 equals 30, just please make sure that you know how to do this stuff. I would first get rid of this 2 to the other side by taking it away. Look at my working out when I'm doing this. Okay, I keep my equals in a neat line, as you'll see as you go downwards. 30 take away 2, I'm going to write the answer below it, so 28. And then I'm going to get y by itself by removing this 7 and dividing it to the other side. And 28 divided by 7 is 4. And that becomes the answer to that particular question. So I don't think I need to do too many more of these ones, but if there is anything else on here that anybody has questions on, then please ask me. There were some weird ones here, weren't there? Okay, I probably should do these as well. Okay, so I'll pick out these two. Okay. Right. In fact, I'm going to do one thing that I do with all the ones I teach. But if I didn't teach you, then you wouldn't have seen necessarily what was about to happen. So I'm going to do two questions. Okay. Right. The two questions you are looking at have the same numbers. There's a 2, a 3, a 5, and a 7, and an X. But they are different questions. And I just want to explain to you why they are different, because it's the kind of mistake that people make quite often. With this question here, what we're going to do first is take away 5, because that is by itself over here, and I could move it and take it away. So I'll have 7 take away 5 on this side, which I'm just going to write down straight away. That's 2. And on this side, we've got 2 over 3x. Right. Then what I'm going to do is move this 3 The way you move a 3 that's being divided is by timesing it. So you times that 3 by the 2. 2 times 3 is 6. And then you move this 2, because it's being times right now, by dividing it. 6 divided by 2 is 3. And that is the answer to that question. Now, the question on the right is not the same because of the order in which you do everything. What was the first thing that we did in this question here? We took away 5, didn't we? We can't do that here because this is technically not a 5. It is a 5 over 3. It is a bit, it's different. You can't do that straight away. It's like it's attached to the 3, so you can't just move the 5 by itself. What you have to do in this question first is move the 3. So right now we're dividing everything by 3. So I'm going to move that 3 by timesing it by the 7. 3 times 7 is 21. And then you should be able to finish this off. And now I can take away the 5. You see, I couldn't do it before until I had moved that 3. Here I could, because it was like by itself over here. Here it wasn't by itself. So take away 5, 21 take away 5 is 16. And then 16 divided by 2 gives you 8. So the answer to the question on the right is 8. And the answer to the question on the left is 3. So yes, there is a difference between these two questions. Yes, I am showing you the difference between the two, even though they look quite similar. Well, they're the same numbers, right? But the way you do the left-hand question is different to the way you do the right-hand question, and therefore you end up with different answers. See that? Different answers to these two questions, even though they kind of look the same. So I'm trying to explain to you the kind of things where people do wrong. People often make the mistake on this question on the right that they take away the 5 first, but then they would go wrong. And so they have to times by 3 first. Here you can take away the 5 first, just to show you. Right, I'll do one more question from here. So this one here. 7x take away 5 is 10. So again, big line. When there's a big line here, you should deal with the number at the bottom of the big line by timesing it. So 10 times by 10 is 100. And then again, from here, we should be okay. We now, because that's a minus 5, I move it to the other side by adding it. 100 add 5 is 105. And then you move the 7 by dividing it. And you 105 divided by 7, which I should know the answer to. 15? No. Yeah. 10,070. Yeah, 15. Yeah, yes, it's 15. Yeah, there you go. Okay, I think that's enough of this booklet. Again, I've sort of shown you there's a difference between this question and the question where you have a bigger line. That's what I was trying to show you earlier. Okay, but if you do have any specific question on any of those, then please tell me. Otherwise, I will just go back to this one, which is a little bit easier. Are there any harder questions down here? Okay, you had the same things over here. Okay. I'll do this question here, 24. So it says xm take away v equals m. And the question is to make x the subject. So see that? X the subject. Okay. So I need to get this x by itself. What I'm going to do, a bit like what we've just been doing in the previous questions, I'm going to get rid of this first and put that there. That will get added because it's a minus right now. It gets added to the other side and we get m add v. And then finally, we just need to move this m away from the x, don't we? And right now it is being timesed by the x. So on the other side, it will be divided. So what you do on the other side is do a big line and put whatever you're moving underneath it. And that will take you to the answer. Okay. Anybody else got any questions on their respective homeworks? It seems like you guys are reasonably confident with it. But pick another one out. Keep doing this. Okay, I'm gonna try some things that are different. No. What I'll do is I'll move on a little bit to something slightly harder. Okay. What we're going to do, and again, you might, it depends on how much you did in the lesson, so I appreciate there's different levels here, everybody. Got, I'm just going to show you how you would do a question that looked like this. Okay. So imagine the question said, solve this. If the question said solve this, then your first problem, solve means find out what x is, right? Your first problem here is that you've got x's in two different places. Somebody tell me the answer. Yep, 27 year 7, I'll come to that. I'll just go through this one first. So you're trying to get the x, the problem is x is in two different places. So what you have to do first is bring them together. So what I'm going to do is I'm going to move this to here. Now, when that moves over, it will minus because it's a plus 2x right now. So when it moves over, it minuses. So you have to do 4x, and you can take away 2x from the 4x. You can't do it with the 5 because it's a different thing. 4x take away 2x gives you 2x. That 5 is still there. And on the other side, the 11 is still there. It's really important that you show you're working correctly here. So I can see that from this line to this line, all I've done is taken away that 2x from 4x. And so I've got to this now. From here, again, you should know what to do. I've got a plus 5. I'm going to move it and take it away from this 11. 11 take away 5 is 6. And then I'm going to divide by 2. 6 divided by 2 is 3. And we have done the question. It just required one extra step at the beginning, which was where you had to. Yeah, x does equal 3. Yeah, we had one extra step at the beginning where you had to bring the x's together first. Okay, so that's just how it slowly what happens with algebra is that your first line starts to get slightly harder each time. But then what you do is you keep making it easier and easier to finish off. That's really what happens as you go down. 27 year 7 has been asked. Um, I presume that's on this page. Because there's no 27. 27 there, the last one. So it says y plus cx equals z. And again, we're trying to make x the subject. So what I'm going to do is I'm going to deal with this first, okay? I know it's on this side, but it doesn't matter. We still do the same thing. You move this y to there by taking it away. So you get z, take away y first. And then to get x by itself now completely, we move this c, and it's being times right now. So you do a big line on the other side, and you move the c to the bottom there, leaving yourself with x by itself. Yes, move the 2x to the other side, put the similar variables together, and calculate the rest. Yes, absolutely, that is what you do. Hopefully that answered the question that 27 year 7 was asked. Let me go back to where I was and make things even slightly more complicated. What I'll do is I'll just keep switching back. If anybody does have any homework questions, then just ask them. Remember, you have until about just before 8. Um, but I'm making it slightly more harder now. Okay, so this time I want to introduce loads of brackets everywhere. I want to make this up, so I have no idea what's going to happen. Um, okay, so completely made up a question here. We're going to solve this equation. Again, if you're in year 7, this is a little bit heavy, but it's okay. We're just going to expand some brackets first. So when you have a number outside a bracket, what you're supposed to do is times everything outside the bracket by everything inside the bracket. So that 3 times is by the 2x. 3 times 2x is 6x. And then you do the same with the other thing in the bracket. So the 3 outside has to be times by the 5 inside as well. And 3 times 5 is 15. So that expands that bracket. Right, I want to see if you can type this correctly. Does I want you to expand this bracket and type what it gives you. Question 9, yeah, right, I'll come to in just a moment. Tell me the page number as well, 'cause I think they're on two different pages, these questions. But firstly, does anyone want to try and tell me what they get when they expand this bracket out on the right-hand side? Minus 2x plus 2. Correct. That is the bit that I was checking. This is a minus 2. It times is by this x and gives you minus 2x. But when you then move on to this number here, that minus 2 is being times by minus 1. Two negatives multiplied together to make a positive, and you end up with that. Very easy to miss, and if you miss it, then you get the rest of the question wrong, obviously. Let's finish it off. So, if I'm going to solve this, I need to get the x's together. So I'm going to take these and move them to here. Because these are negative, they will come over and get added to this side. 6x add these 2x, make 8x. And on the other side, we have a 2. Then I'm going to move the 15 and take it away from the 2. 2 take away 15, be careful, is minus 13. And then, lastly, I'm going to just divide the 8. And when you get these weird fractions that don't give a nice whole number answer, 13 divided by 8 is not a whole number answer, you could just leave it as a fraction. I think sometimes people overcomplicate it and start thinking about decimals and things. You don't need to do any of that. Just move the 8 below it and stop. Because you're if you try to do more now, you're at risk of converting this wrong or you know changing it to a decimal wrong. So you've gone from the right answer to the wrong answer if you do it wrong now. So why not just stop at the right answer? If the question says write your answer as a decimal, obviously you then have to do that, but none of these did. Question 9 on year 8. That'll be this one. I assume you're asking me for question 9 on, oh, question 9. Which question 9 is it? Is that down here somewhere? You might need to confirm what you mean by question 9 because they are lettered. And also what page. So on the top corner, it'll tell you a page. So if you do page 4 and then A to O, which one you want, or page 8, A to L. Is it unlikely that if it was an exam question, it would ask to convert into something like that? I would say for that question that I just did, it would be very unlikely that they would write the answer as a decimal. What's possible is they say write the answer as a mixed number or a mixed fraction. A mixed fraction in this case would be minus 1 and 5 over 8. That's more possible, but only if it tells you to do it. Don't know how I would do it. Question 5, yeah, 9. Yeah, 9 booklet. Okay, that's okay. Um, okay, in booklet 3, question 5. Are you asking me for question 5 on the first page or oh maybe that or the second page? There's 2 pages of question. Oh no, there's only 1 page of questions. Sorry, never mind. Okay, I thought there were 2. So question 5 says mx squared equals t add a. Now, I can understand the confusion here, and it's probably the brackets. Um, First of all, um, when there's nothing outside the brackets, it doesn't matter that the brackets are there. So it kind of is the same as just that. There isn't really any difference between this and this. It's like having a one outside it. One outside it doesn't do anything. So you can leave the brackets there if you want. Either way, it doesn't actually affect what you do next, which is you would need to move this m. Remember, we're trying to make x the subject. So we're going to move the m first. And when you move the m, because it's being times right now, it gets divided. So you get t plus a over m. And then, if we just move over to here, when you have x squared and you don't want the squared, what you have to do is square root on the other side. And when you have a fraction, you just do like a big square root like that. So everything gets covered like an umbrella. And that would be the answer. I guess you can put plus or minus in front of it, but I wouldn't. So you're okay. And yeah, so I appreciate the brackets there made it seem like it was a problem, but it actually makes absolutely no difference. So you could leave the brackets there if you like. It doesn't actually change anything. Or you could not have them. Yeah, it is that. Again, somebody asked me question 9, year 8, which I don't quite know what that means, unless you mean this booklet. But you do clarify if you want. And then what I'll do is I'll do one more question. Oh, there's more questions. Question 18. Yeah, no. Okay, question 18 now. Right, question 18 on here says, if we just take that from here, there it is. That's question 18, right? The same one. Um, okay, so it says that. That's what it says. And we have to make X the subject again. So let's do this slowly. We are going to first move this plus Y away to the other side, leaving you with Z, take away Y on the right-hand side. And on the left-hand side, you just have this still there. So X squared M. Right. Now what we're going to do is we're going to move this M away. You should always deal with this squared thing last. It's actually the opposite of BIDMAS. But I'll do that another time. So you need to just move this M. Okay. And again, because the M is being timesed by all of this, it gets divided to the other side. So you get Z, take away Y, big line, and an M underneath it. And then the last step is the same as it was in the previous question, which is if I want to get rid of a squared, I do a big square root and just put everything that's on that side inside it. You end up with the answer. Okay. Anything else? Any question, anybody? No? If not, I will do one more question, then we'll be done. Just I'm going to make up one more. Um, okay, what did I do before? I did that before. How do I make this more complicated? Okay, let's do something silly. Oh, there's one more question. Question 11. Would you just put a square root? Question 11. For this one, um, no, I'll tell you. So in question 11, it says x squared plus n squared equals a squared. Okay. I appreciate this is again a slightly harder question. So since we want to make x the subject, what we should do is get rid of anything that's near the x completely. So for this, we can move all of this to the other side. So we don't have to do the square root thing here because we're not trying to just get the n on its own. We're just trying to move the whole thing away. So what happens is you get a squared, and then this entire plus n squared becomes a minus n squared on the other side. And then, because we want to get the x by itself, this is where we would then square root everything on the other side. And that's how you would leave the answer. It takes a bit of practice because they're all slightly different, all these questions. But that's why we're doing it. So, Right, I'm going to make one up finally. Right, we're going to make x the subject in this question. Oh God. Ax squared plus b minus c plus d minus e plus F, I remember my alphabet, over G plus H equals J, missed out the I deliberately. K. Okay, right. We're going to make X the subject of this equation, and then we're going to finish. Um, okay. So first things first, because you have a big line here, we're going to move everything underneath it to the other side. Okay. So we're going to, on the right-hand side, we will have JK, just kidding, times by G plus H. And you could, this is how you write it when you've got, think of that as like a bracket. When they're being added together, we're moving the whole thing and timesing it. And I'm going to leave it like that. On the left-hand side, I've got ax squared plus b minus c plus d minus e plus f. Okay, and then I'm going to slowly move. Remember, I'm trying to make X the subject. So I'm going to move all of these things to the other side. So I'm going to do it all in one go. So on the right-hand side, I've still got JK times G plus H. So leave that as it is. When I move the B, it will become a minus B on the other side. When I move the minus C, it will become a plus C on the other side. When I move the plus D, it will become a minus D. When I move the minus E, it will become a plus E. When I move the plus F, it will become a minus F. Right, done that. Then I am going to move this A. This A is being times by the x squared, so I'm going to divide it to the other side, and I'm going to have J, K. Look at how I do my working, by the way. This is really, I'm doing this to show you how important it is for me to keep my working clear. When it gets really complicated, it's really important that each line is clear for what you're doing. So JK, G plus H in brackets, minus B plus C minus D plus E minus F. And the A has been divided to the other side. So big line and A there. Nearly finished. Um, to make X the subject now, because it's X squared, I'm going to square root everything on the right-hand side. So I'm going to have to write it all again. I could copy and paste here, but I shall continue. JK, G plus H minus B plus C minus D plus E minus F over A, and then that square root from this squared just goes over everything. And I have made X the subject of that original equation. Given that there are no further questions, I will stop there and I will return in 8 minutes for anybody in year 10 and year 11 that wishes to do some maths. Right. My intention for the remaining time is probably to do the entirety of the Year 10 and Year 11 booklets quite fast. Because I think that's the best way to just help, really, and just do the whole thing. So I'm going to do it now, starting with the Year 10 one. It won't take long, and then I'll move on to the vectors in Year 11 and just do the whole thing. Okay. Um, and I will often do that with maths. So, first question here asks you to solve this equation. We are going to expand the brackets, and that will give me 4 times 3x is 12x, 4 times minus 2 is minus 8, equals 2x minus 5. I need to get the x's together. Just keep an eye on questions. How to use the ratios in the vectors. But yeah, I'll do that. But the ratios in the vectors are the trickiest thing. So the best way to do that is to just do some questions, and I'll see what there is in the booklet first. If not, I will pick out a couple other ones that I know are available somewhere that I have. Because the vectors, the ratio is the hardest bit of vectors. So that's the expanded brackets, and then I'm going to move this to that side, and that'll give me 10x, take away 8 equals minus 5. Then I will add the 8 to minus 5 to get 3. And then I will divide by 10, and I'll just leave my answer as a fraction. If you want to change it, you're welcome to. But that would be that one. Like, remember, all of this is recorded. You can get it later, should you need it. Equilateral is an important word. It means that all three sides are equal. And therefore, what I can do to answer this question about the perimeter, because I can't answer this question, is the perimeter bigger without knowing the perimeter? And I can't know the perimeter without knowing what x is. And so this is how you have to think through these slightly harder maths questions. I need to figure out what x is. How can I figure out what x is? Well, I do know that this is the same as this because they are equilateral. So I can write that down and say 6x take away 10 equals 4x add 5. And then I can solve this equation in the way that we've been doing by 6x take away 4x is 2x. Always keep looking at my working out to see how I'm showing it all the time. I can then, that minus 10, I can add to the other side. Keep an eye on questions here. Yeah, doing it all, don't worry. 2x equals 5, add 10, which is 15, and then divide 15 by 2. 15 over 2 is 7.5. I'm going to put this as a decimal because I am now going to, now that I know what x is, the question is not finished. Now that I know what x is, I can substitute 7.5 into where that x is. 6 times 7.5, take away 10, is 35. Which means that this side is 35 centimeters long, and it's an equilateral triangle, so that's also 35 long. I don't have to work it out. And that's also 35 long, which means the perimeter of this triangle is 35 add 35 add 35, which is 105 centimeters. And so is the perimeter greater than 1 meter? 1 meter is 100 centimeters, and we've got 105. So yes, it is. Move on. This one, again, I'll do this reasonably fast. Take away 6x, you get 2x. Don't forget this is a minus 9. It stays stuck to it. Then add the 3 to minus 9. Be careful again. Minus 9, add 3 is minus 6. And then divide by 2. Minus 6 divided by 2 is minus 3. Solve this. Square root it. You get 6. You could put plus or minus if you want to be absolutely thorough about it. Algebraic, I'm surprised nobody has asked this because these are the toughest ones unless you just did them in class. But the way you do this is you add these fractions together first. Don't worry about the 2 on the other side. We'll deal with that later. To add fractions together, you get a common denominator, which in this case will be the product of 3 and 2, which is 6. You then cross multiply, basically. You do 2 times that and 3 times that. 2 times all of this is 2y add 2. You times the 2 by the y and the 1. Then you do 3 times that, which is 3y minus 6. You then simplify the top there. 2y add 3y is 5y. 2 take away 6 is minus 4. Okay, now that you've got it to here, this is why we did all of that. You get a single fraction that's much easier to solve now because I can times the 6 by that to get 5y take away 4 equals 12. Then add the 4 to get 16 and then divide by 5 and you get 16 over 5. This one, solve. Times the 6 over, 2w take away 3 equals 24. add the 3 to get 27, divide by 2, leave it as a fraction if you want, or turn it to 13.5 if you like. Keep an eye on questions. Can you please go over question 4? Yep, I want to do the whole booklet. So don't worry, if you want to ask me specific questions, the whole thing is going to get done. This is hard to explain because this shouldn't really be in this booklet, but I'm going to just do it. This is more relevant for the year 11s here, really. But I'll just tell you how you do this, okay? You're not expected if you're in year 10 really to be able to do this yet. But you're supposed to factorize this, and you factorize this to 2x plus 5, 2x minus 5. This kind of fell into this booklet accidentally. Okay. And then when you solve this kind of equation, you basically do the opposite of what's happening in the bracket. So if you're adding 5 and dividing by 2, you take away 5, sorry, adding 5 and timesing by 2, you take away 5 and divide by 2. So you get x being minus 5 over 2. And if you do the same with this bracket, you get x being positive 5 over 2. Now, if it had been an equals 0 question, this would just be equals these answers, but unfortunately they're not in this case. When it's a less than 0 like that, what you're supposed to do is think about a quadratic graph. Think about what you just found. You just found that that is 5 over 2, and that is minus 5 over 2. And you're being asked about where it's less than 0, which is this section here. That's underneath the axis. And that would be where x is bigger than minus 5 over 2, so in that direction, or in the other direction from the other one, so less than 5 over 2. You're not meant to know that, so don't worry. Yes, so questions 2, 9, and 7b. Right, I've already done 2, just so you know. It's all done. I'm doing the whole booklet. So what you can do is you can just go back to the YouTube video, which will be recorded and be there shortly, and just watch it back. So this one, solve this. When you're solving an equation like this, again, when there's a fraction when there's a fraction, you should just times everything on the bottom over, because then it gets rid of the fraction. Like so. Expand the brackets, you get 5y take away 30, and then solve it. So add the 30 to that to get 31, and then divide the 5, and you'll have your answer as 31 over 5. Okay. Question 6. Square. What do we know about squares? We know that the sides are the same length, which means that whatever this 7x take away 3 is, it is exactly the same as this. And by setting out this equation, we can work out what x is, because that's what we have been doing. If we expand the brackets, you get 3x plus 3. If you move this 3x to here, 7x take away 3x is 4x. If you then add this 3, well, it's minus 3, so you add it. So it becomes 3 add 3, which is 6. And you then get 6 over 4. 6 over 4 is 3 over 2, or 1.5. Don't think we're finished, because the question says work out the length of one side of the square. So now that I know that x is 1.5, I could just put 1.5 into here and work out what it is. 7 times 1.5 take away 3 tells me that the side is 7.5 centimeters long. Just be careful of that. So with these questions, you sometimes just sort of get to x equals and think you're finished, because you're like, well, that's what you normally are, right? You think you're finished, I've got x. But that's not always the case. So in this case, it wasn't the case. This question, not the easiest question, this one. I'm going to take away the 2. Then I'm going to times this 5. But when I times the 5, I'm going to times it by everything on the other side. So it gives me 5x minus 10. And then from here, it's easier to solve. So again, the idea of algebra is you're trying to make the question easier for yourself. I'm going to take away this x to get nothing on that side and 4x minus 10 on this side. Then I'll add this 10 to get 10 equals 4x, and then 10 divided by 4, or 5 over 2, would be the answer. This one, another algebraic fraction. Again, I'm going to do this quite fast. When you're adding fractions, leave this equals 1 till later. Do a big line, times those two together, 12. Then times that by that, and this by this. We'll do it all quickly. 3 times all of this is 6y minus 9. 4 times all of that is 4y minus 16. Then you can simplify that top. 6y add 4y is 10y, minus 9 minus 16 is minus 25, equals 1 is still there. And then from here again, you can, this should be quite easy, times the 12, add the 25, and divide by 10. 37 over 10 is fine, or 3.7 if you wish. Expand and simplify. Should be easy. 5 times x is 5x. 5 times minus 3 is minus 15. Be careful here. Minus 3 times x is minus 3x. Minus 3 times minus 1 is plus 3. 5x take away 3x is 2x. Minus 15 add 3 is minus 12. That's where your negative numbers are important. Solve this equation. Same, done loads of them. There is a shorter way to do this, but I want to stick to the longer way. Big line, 2 times 8, 16. 16. 8 times all of that is 8x plus 16. 2 times all of that is 4x plus 2. So same method every time. Times those two together, times that way, times that way. And it creates one big fraction. And then simplify this fraction. 8x plus 4x is 12x. 16 add 2 is 18. Then times the 16 by 0. It'll give you 0 still. And then you should be able to finish that off. Take away 18. And then divide by 12. If you'd like to simplify it, then it is minus 3 over 2. All right, this one. This is probably the trickiest question in this thing. Work out the values of x and y. So there's a trick here to realizing that if I have a square and it has told you the area is 100 centimeters, then you know something about that square, because the only way a square has an area of 100 is if it's 10 by 10. That's the only way, because you have to time them together. They have to be the same because it's a square, and they times together to give 100. So 10 is the only option. And so this here is 10. So what I'm going to do is I'm going to write down that side, 4 times 3x minus 2 equals 10. I'm going to ignore this one, mainly because there's an x and a y in it. I can't do much with it when there's 2 letters in it. Expand the brackets, you get 12x minus 8 equals 10. 12x equals 10 add 8, which is 18. X is 18 divided by 12, which is 3 over 2 again, isn't it? There's loads of 3 over 2s in this. Or 1.5. Right, so I've worked out that x is 1.5. Right, and if we go back to this now, remember this has to equal 10 as well. So 8x minus y equals 10. I know what x is now, though. X is 1.5. 8 times 1.5 is 12. So 12 take away something is 10. That something must be 2, right? So I've worked out what x is and worked out y. The answer to when are we going to do functions in maths, it is one of the topics this year. I'll have to just check the timetable, but it is one of the math topics that I have specifically allocated to year 11. We do functions and something called graph transformations together because they're sort of linked. Oh, and that's it. Done it. Wow. Okay, that's the whole homework. Finished. Right, that's it for the year 10 homework. The year 11 homework on vectors. 10 instead of x. Where? I don't know what you mean by 10 instead of x. No, not 10 instead of x. Sorry, I don't understand what you mean. Because I'm not saying that x is 10, I'm saying that all of one side is 10. So all of that is 10. So that equals 10, not x equals 10. I use that to work out what x is, but it's not that x is 10. Yeah. So it's not that x is 10, it is that the whole side is 10. Okay. Right. Vectors. I have not seen this booklet, so I'm not entirely sure what's to happen here. Right. The vector minus 2, 3 translates A to B, circle the vector that translates B to A. Right, what this means is, I'm going to try and thoroughly explain this. especially if any of you were in Manchester, and therefore I, for reasons, did not actually do the lesson. The vector minus 2, 3 translates A to B. Circle the vector that translates B to A. Minus 2, 3 means that you go 2 left, because it's minus 2, and 3 up, sorry, and 3 up. Okay, that's what that means. So it's a line that basically goes sort of in that direction, where it's 2 to the left and 3 up. Okay, it's actually easier to do this on squared paper, but I'm not going to do that now. Oh, yeah. Um, so that would be A to B, minus 2, 3. So it's this line here. Okay. Now the question is, what's the vector that's B to A? Now B to A is just everything in the opposite direction, but we have to do the opposite X and the opposite Y. So it's going to be, rather than 2 to the left, it's 2 to the right, that's positive 2. And rather than 3 up, it's 3 down, so it's minus 3. So the answer, a long-winded explanation to that, is that that is the answer to the question. But simply put, you just make these values negative. So you change the signs. So minus 2, 3 becomes 2, negative 3. Um, God, right. P to Q, and this is, as I said, in vectors. I mean, these are relatively straightforward questions, but in vectors, the ratio part of vectors is the worst part of vectors. Um, So it tells you that PQR is a straight line. P to Q to R is 3 to 1. The way I think of this is that imagine that this line, P to Q, is like 3 centimeters long. It's not, obviously, but pretend it's 3 centimeters long. And Q to R would be 1 centimeter long, right? It's in the ratio 3 to 1. One is 3 times bigger than the other. So if they're telling you that P to Q, we're going to call that the vector A, right? The question is, what is R to Q? Wow, it's a complicated one. Firstly, let's focus on what Q to R is. So, would you agree that if you traveled from P to Q and you did 3 miles, 3 centimeters, whatever, then for you to go from Q to R now would be 1/3 of what you did before, because 1 is 1/3 of 3, which means that this vector here is 1/3 of whatever this vector here is, and it's A. Okay, so that whole vector is A, which means that this little bit is 1/3 of it, because 1 is 1/3 of 3. However, the question is not Q to R, the question is R to Q. If you go backwards on a vector, R to Q, then you just make it negative. So it'd be minus 1/3 A. And that is why minus 1/3 A is the answer. It's negative, yeah, so I've done that, haven't I? Sorry, I think you might have um something. I don't know what the word is. No, I guessed before I fixed it. Right, next one, 3. Work out A plus B plus C. When you add vectors together, when they're like this, when you have the actual column vector, you call these column vectors, the actual numbers, you literally just add the numbers together. So A plus B plus C just means adding that to that to that. So 6 minus 1 is 5, minus 4 is 1, and minus 10 plus 2 is minus 8, isn't it? Yes. Minus 8 plus 7 is minus 1. Okay, I think that's the answer. Please tell me if you disagree. Um, Show that A plus C 2C is KB, where A is an integer. Right. So A plus 2C. So A is the vector 6 minus 10. Okay. C is the vector minus 4, 7 from this question. Okay. And there's 2 of them. So I'm going to put a 2 there and put a plus in front of them, like that. Um, Now let's figure out what this is. Firstly, that 6 minus 10 stays as it is. And this vector, because I've times it by 2, it's 2c, becomes minus 8, 14. Okay, so you've doubled it, minus 8, 14. And then let's add them together. 6 take away 8 is minus 2, and minus 10 add 14 is 4. Okay, it's got minus 2, 4. And then it's saying, show that this is something times b. So what was b? B was minus 1, 2. So how do you get from here to here? I mean, you can tell by looking that you times it by 2, because that gives you minus 2, 4, which means that the k is 2. So we're saying that that vector a plus 2c is the same as something times b, It is 2 times b, isn't it? Because we had minus 2, 4, and we're saying that b is minus 1, 2. If you double that minus 1, 2, you get to minus 2, 4. So k is 2. Okay, fine. Question 4. Is BCD a straight line? Show work and support your answer. If you get this straight line scenario in vectors, which is again a very common thing in vectors, then, as I told the people that I taught, certainly, the way to do this kind of straight line BCD thing, is work out the vector B to C, so the first two letters, and then work out the vector C to D, so the second two letters. And then just see what happens. Okay, that's all. Because you'll start getting marks if you do that. And remember, it's about getting more than 0 marks in these questions. Not necessarily getting all of them, but making sure you don't get 0. Um, so what is the vector B to C? If I'm on B and I'm going to C, well, I can't go directly that way because I don't know any vectors here, but I can go that way and that way. Okay, so I can do 5a minus 2b to get from there to there, and then go backwards on this one. Be careful. If you're going backwards on a vector, the whole thing becomes negative. So 3a plus b becomes minus 3a minus b. So if I simplify this, 5a take away 3a is 2a, minus 2b minus another b is minus 3b. So that is the vector b to c. Done. Let's do c to d. So I'm on C and I want to get to D. I can't go directly because I don't know any vectors here, but I can once again go that way and then that way to get from C to D. 3a plus b gets me from C to A. And then because this is the correct direction, that arrow, I just add on 3a minus 9b. Don't need to make it negative this time because you're not going against the arrow. What does that simplify to? 6a. 3a plus 3a is 6a. B minus 9b is minus 8b. And then you just look. So the answer is no to this question, but let me tell you why. Um, by going off topic slightly. If I have a vector a plus b, right, and it looks like this, okay, let's just say. And then I said, let's draw 2a plus 2b. Then one thing I know about these two vectors is that they are going in the same direction. One is just twice as big as the other. That 2, the 2a and the 2b, just means it's twice as long, but in the same direction. Um, B is the starting point. Maybe I've done it wrong. Let me say B is the starting point. Why not count 2a minus 3b? I'm not sure what you mean, but I can explain that to you when I see you. But I was trying to work out what B to C was, so I went from there to there, did that. Then I was trying to work out what C to D is, so I went from there to there. So that's got nothing to do with this vector. Um, or, oh, I see what you mean. So you're saying that B to C is 2a minus 3b, so why not look at that? You don't need to, is my point. You just do what I said, which is work out this vector, and then what I'm about to explain makes sense, which is that if two vectors are parallel to each other, they will be multiples of one another. So for example, 2a plus 2b is parallel to the vector a plus b. Similarly, 3a plus 3b is parallel to the vector a plus b because I've times them both by the same number. Um, so as long as I can times a vector by something like 5 to get a new vector, those two vectors will be parallel to each other. And so if B, C, and D is a straight line, then this to here, which is 2a minus 3b, should be parallel to C to D. Because if two lines are parallel and they're joined together, that makes a straight line, doesn't it? These two lines are not parallel, and therefore this whole thing is not a straight line, is it? It's only a straight line if they're the same direction, if they're joined onto each other. And so if I can show that these two, if I can look at these two vectors and check if they're parallel, then I'll know. And are they parallel? No, because can you times this by something to get to there? You can't, because you times the 2 by 3 to get to 6a, but if you times the 3 by 3, you should get minus 9b. If that's at a minus 9b, they would be on a straight line. But the point is, you cannot multiply um, the first vector by anything to get to the second vector in its entirety. That means they're not parallel to each other. So all I would write at this point is that these two vectors are not parallel, and which means that BCD is not a straight line. They would have to be parallel for it to be a straight line. Um, so you worked out B to D, fine, and then proved that BC and CD added up together. Is that fine for proof, or do I ensure they are meant to multiples? But they wouldn't have added up, right? Um, BC and CD added up together. Um, how does parallel link to straight line? I'll tell you in a second. But I'm just trying to check if that works. I worked out BD, so that would have been 5A minus 2B. So BD is 8A minus 2 minus 9 is minus 11B. And then you proved that BC and CD added up together. So BC is 2A minus 3B. CD is 6A plus 8B. Oh, no, that doesn't work because that doesn't tell you if they're straight. Um, so let me explain what you have done. Let me give you a crazy scenario to show what you have done. So that doesn't work, actually, what you have just done. Because that would always, yeah, because that doesn't that doesn't tell you anything about straightness. So let me give you a scenario. Imagine this is B, C, D. Okay, right. So what you have just worked out is the vector B to D, right? And then you have shown that B to D is B to C add C to D, which it is. Definitely it is, because that's how vectors work. You've just added them together. Oh, and it does add up. But that's not a straight line. So that the fact that they add up doesn't mean that it's a straight line. It means that they're just joined together. But they can be joined together at an angle. And so they're not going to be parallel to each other. So yes, it adds up, but it would always going to add up. It would add up regardless. So see what I mean is if I don't know if this is gonna work. Oh, look at that. Right, if I do that, right, and join that to the end of here, it still adds up, right? But now it's straight. But before it would add up and it wouldn't be straight. And that's it. The point is vectors add up if one's joined to the other. That's it. That's irrelevant as to whether it's straight or not. The only way to prove straightness is using the concept of one being a multiple of the other or not. And we know that doesn't work because I have just proved that this is not a straight line. And according to you, it is a straight line. So one of us is wrong. Definitely. So that's the point. Let me answer the previous question. How does parallel link to straight line? Well, I'll tell you. Well, there it does there. You see how this line is not parallel to this line, is it? Right? Definitely not. Which means that if I join them up, do I get a straight line? No, you don't get a straight line. You get a line that's bent, obviously, because these two are not parallel to each other. But if there were two lines that were parallel to each other and you joined them up, you get a straight line. And that hopefully answers your question as to how straight line links to parallel or the other way around. How did you find the length if you didn't know the original number? I didn't ever find the length. I don't think I found the length anyway. Did I find the length anyway? Um, I didn't. I'm just proving that with vectors, you can figure out the whole point of vectors is it's about direction. And two vectors are going in the same direction if one is a multiple of the other. These two vectors are not multiples of each other. You cannot times this first vector by anything to get to this vector, which means that they are not parallel, so that when you join them up, you're not going to get a straight line because one of them is going to be, well, they're going to be bent in the middle, aren't they? How do you know the two sides are parallel? You don't. You're trying to find out if they are using vectors. Also, you're an anonymous attendee, which is not a fan of. Um, but that's the point. You don't know the two sides are parallel. You're trying to check if they are, Because if they are parallel, then all of this is a straight line. If that is parallel to this, if they're going in the same direction, then it's a straight line. But what I just proved just now is that one of them is the vector 2a minus 3b, and the other one is a not the same direction. So, I mean, on an exaggerated point, it's like that. You see what I mean? If it would be, I know it looks straight here, but we have proved that they're not. And that's the point. Um, could you do what I did? The question asked, are they on the same line? Yeah, you could, but they're not going to ask you that because you can see they're on the same line. So why would they ask you? Um, you see what I mean? You can see they're on the same line. B, C, and D are on the same line. Um, but they're not necessarily a straight line, and that's what you're trying to show. Complicated. But that's why, just so you know, though, those of you in year 11, I have chosen the maths topics that you are doing this year deliberately, because obviously we can't do absolutely every single maths topic in the world, but I've deliberately chosen the topics that I think are the ones that come up with the most challenging questions in maths exams, such as vectors, which is that's why we're doing it. Circle the vector 2a plus b. 2a means you double all of this, which gives you minus 8 minus 2 plus b. B is 3 minus 1. Add the tops, minus 8, add 3 is minus 5. Add the bottoms, minus 2 minus 1 is minus 3. Is there a minus 5 minus 3 here? Does that? Well, will the exam be similar to this worksheet? No, it won't be similar to this worksheet in the sense that your exam is not going to be full of vectors questions entirely. So therefore, no, it's not going to be like this. You will get one vectors question across 3 exam papers, which is the unfortunate reality of maths, is that you do all this stuff practicing so much for one topic, for one question on it in most situations. But that's just how it works. So no. But in terms of difficulty, yes. But sometimes I don't think these questions are particularly difficult vectors questions. You get some hard vectors questions, and again, I did some of them in the lessons that I taught. But I think these are manageable generally. Show that BCDE is a parallelogram. Right. Let's just talk parallelograms. I might even have a sketch of one here. Parallelogram somewhere here. Oh, look at that. Right, here is a parallelogram. Okay, what do we know about parallelograms? We know that this side and this side are not only parallel to each other, but they're also exactly the same length. So in terms of vectors, remember what a vector is? It is a line with a certain size and a certain direction. These two in red must be exactly the same vector because they're going in the same direction and they're the same length. Similarly, these two lines are going in the same direction and they're the same length. So therefore, they must be exactly the same vector. Sides are equal is a little bit vague. The opposite sides are the same length and are parallel. That's what parallelogram is. Okay, so to show that BCDE is a parallelogram, BC, I hate saying the word parallel. BCDE. Okay, right. Clearly, it doesn't look like a parallelogram, but that's irrelevant because this is not drawn accurately. So the fact that it doesn't look like it is not relevant. What we need to do is look at the opposite sides. So let's take this side and this side. And we need to find out what their vectors are. Because if they're the same, and then look at these opposite sides, that one and that one, then if their vector's the same, then this is a parallelogram. Because as I said, if the opposite sides have exactly the same vector, then they're the same direction and the same size, which is the definition of a parallelogram. So let's, God, right, we've already got D to E, right? So D to E is A minus 3B. So I don't need to do anything with that. C to B is the other one. So I'm going to compare that to this one, right? That's what I'm trying to do. I'm going to compare that with this. So can we figure out what C to B is? Right, C to B is, right, the only way around here is to go, I want to get from C to B, right? But I can't go directly there. So I want to go there, then there, then there. That's what I'm going to do. Okay, so C to B is against this arrow, so that's the opposite sign. So you got to make it all negative. So that's minus B plus 2A. Then you're going to go this way against that arrow. So that's minus 2b. Then you're going to go this way against that arrow. So minus a. What does that simplify to? 2a minus a is a. Minus b minus 2b is minus 3b. Look at that. We have ended up with for c to b as being the same vector as d to e. So this side, well, I won't do that. The two red lines in that diagram are the same vectors. This is also a minus 3b, which means they're the same size and they're parallel. So that's good. So far, that's good. We're heading towards a parallelogram. We need to do the same with the green lines that I have drawn here. So, right, B to E. Let's start with this one here. I can't go directly there, but I can go there and there, which is easy because it's just A plus 2B. Then I need to check the same for C to D and see if it's the same thing. C to D, how will I do that? I can't go directly there, but I can go from C to E and then E to D like that. So I can add those two together. So I want to go that way against the arrow. So that's minus B plus 2A. That takes me to there. And then I'm going to go this way against the arrow again. So make that negative minus A plus 3B. Be very careful with your negatives because that will mess up everything. C to D, let's simplify. 2A minus A is A. Minus B plus 3B is plus 2B. And you have shown that C to D is exactly the same vector as B to E. Therefore, this is a parallelogram because this is A plus 2B and this is A plus 2B. The opposite sides are the same vector, therefore they are parallel and the same length. This opposite sides are parallel and the same length. This is a parallelogram. It's a long question for 3 marks, but you know. Okay. God, didn't know how long this is. Let's keep going. Times. Another parallelogram. ABE is a straight line. Right, this is the sort of vector, the ratio stuff. AB to BE, 3 to 2. Right. So AB is there, BE is there. They've told you it's in the ratio 3 to 2. So I like to write that down just below it. It doesn't really mean anything, but I like to write it down just to sort of suggest that imagine if that's 3 centimeters long, then that's 2 centimeters long. Okay. Let's see what the question wants first. So they've told you that the vector A to B is A, and the vector A to D is B. Right, I'm going to do something with the ratio now. This vector is A, and it is in the ratio 3 to 2 with this vector here. That means that this side is 2/3 of this one, right? Think of it as a line that's 5 miles long. If it's this up to here is 3 miles and this is 2 miles, then this is 2/3 of that line. Okay. So if that line is A, then this line is 2/3 of A. I'm going to write that down here as a vector. And this is where this gets a little bit complicated, this, okay? But that is the situation. So that B to E is 2/3 A. It is 2/3 of the A to B line because it tells you effectively that. A, B, B, E is in the 3 to 2. Okay. All right. Work out B, C, and E, D intersect at F. Oh, no. It's going to be quite a long question, isn't it? If anybody's saying anything. How do we know the direction? Because it's the same as that. That's it. That's the answer to your question. It's the arrow. Okay, I'll do the first part. I might not do the second part because it might take a pretty long time to do. Oh, maybe I'll see. I'll see. Right, E to D. E is there. D is there. So if I'm going to get from E to D, what I'm going to do, because I know these vectors here, I'm going to go this way and then this way. Right. So if I go from E to B, I've got to go against this vector. So that's minus 2/3 a, because I'm going against the arrow. And then minus another a, because I'm going against the arrow, plus this b, because that takes me to the top there. Minus 2/3 minus 1 is minus 1 and 2/3, or you can write it as minus 5/3 is probably how I would write it. That should be the answer to the question. Um, because and that's why you needed the ratio, because without that you'd struggle. Do we just leave AB as A or make it 3 over 2A? AB is A though. Why would you change that? You see what I mean? A to B, they've told you in the question that A to B is A. Don't change what's in the question. So A to B is the vector A. Done. B to E is a bit less than it, right? And it's 2/3 of it, basically. So that's what B to E is. And then do I want to do this question? E to F in terms of E to F. F. Let me just have a think about if I want to do that or not, because it might be a bit too complicated. Um, yeah, I'm going to move on just because it'll take just for time reason. I want to get through as many as I can. Here are two column vectors. This is easy enough, isn't it? In fact, no. What I'll do is I'll go. I'm going to leave these ones because this is easy. This one does it have a ratio in it? It doesn't. But I think, but it is quite complicated. So work out the vector A to B. That's there, right? But I can't go directly there, but I can go there and then there. So I'm going to go on that arrow, A plus 3B. And then I can add on this one, because it's with the arrow still, minus A plus B. No need to change any signs. A minus A is nothing, and 3B plus B is 4B. I think that's the answer to that. As in, it just means work it out. So don't worry about the word deduce. Like that's an unnecessary way of saying it. It's just it requires a little bit more thinking. That's all. So they'll just try to be fancy about it. Right. Also, E to D is 1/3 A to E. Right. E to D, which is this little bit here, they've told you is 1/3 of A to E. And A to E is that. So this is 1/3 of this, right? A plus 3B. Okay. And D to C, oh God, I assume that says minus 1/3 A. Looks like it's not a great typo. Yeah, I'm gonna go with it. D to C is minus 1/3 A. Okay. Prove that EC is parallel to AB. And remember how we show that they're parallel? You just work them out separately, and then see what you get. So we're gonna try and work out E to C and work out A to B. Do we know what A to B is already? A to B, yes, we did. We worked out in the last question. It was 4B. E to C is this here, and we're just going to go this way, then this way, right? So that is this plus this. So 1/3 A plus 3B. And then add this on, which is minus 1/3 A. Okay, let's expand the brackets and simplify. 1/3 A is 1/3 A. 1/3 times 3 is 1. Your third A's cancel, leaving you with B. So that first vector is B, the other vector is 4B, and that proves that they are parallel because I can go from here to here by just timesing by 4. If one vector can be multiplied by something to get to the other one, then they are parallel to each other. So B can be times by 4. It's just 4 times bigger, essentially. I don't think I need to do question 10, but then I will do this as time. Yeah. Okay. AFE is a straight line. Okay. AF to FE is 3 to 2. So this is what we have to struggle with, right? AF, FE is in the ratio 3 to 2. So if they've told you that this vector is A, this vector is a bit bigger than that, isn't it? In fact, quite literally, it is 1.5 times bigger than that because 2 times 1.5 gives you 3. And this is what you have to do with ratios. You have to kind of deduce a word, what is going on with the ratio. So if they've told you it's in the ratio 3 to 2, then you can figure out in terms of vectors what one of them is, because it's just a certain number of times bigger than the other one. So it is 1.5 times bigger. So this is 1.5 or 3 over 2a that way. Same direction, okay, as the previous one. So that's the first thing that I've got out of there. DE, which is here, is 2CF. Okay, so I know that this line is twice as big as this line. Might need that in a minute. Yeah, we'll see. Oh, E to F is A. I've labeled that. A to B is 2B there. C to B is 3C there. Okay. Work out D to E in terms of A, B, and C. Um, oh, that's easy. Right. So, because I know that D to E is just double this C to F, because it tells you in the question. If I can just work out what C to F is, then I can just double it, and that'll get me what D to E is. So can I work out what C to F is in any way? So C to F is there, right? Now I can't go directly, but I can, because I've got all the vectors I need, go this way, and then this way. And that will get me from C to F. Let's add those up. C to B is 3C. Then we're going that way on the arrow, so minus 2B. And then we're going that way on the arrow, so minus 3 over 2A. Okay. Can't simplify that because there's A, B's, and C's. But then C, so that's C to F. And the question is D to E, and I know that D to E is double that. So let's just double everything. 6C minus 4B minus 3A. You double that. And that will take you to the answer. Okay, right, a couple more. In triangle ABC, M is the midpoint of AC, N is the... okay. M is the midpoint of AC, so M is exactly halfway, that's nice. N is the point on BC, such that BN to NC is in the ratio 2 to 3. This is where it's slightly different, so it's a good question to see this. So I've just put that 2 to 3 in thing. Oh no, that's from the wrong place, isn't it? The other way around. BN to NC is in the ratio 2 to 3. Mean. A to C is the vector 2A. So they're telling you that all of this vector is 2A. Now, because M is halfway, what I can do is call that 1A and call that another A, because it's split, isn't it? 6E plus 4B plus 3A. I don't know, did I make a mistake? Because that was a minus, so we went against this arrow, so it was minus 2B, wasn't it, to start with? And then you doubled it to minus 4B. And then we went against that arrow, so it was minus 1.5A, which I doubled to minus 3A. So that's my explanation for that. So I've done this A and A. A to B is the vector 3B. Okay, so I'm going to put that in. In this particular exam board questions, they you have to put the bits into the diagram. In some of them you don't, but it's not difficult. Right, the question is M to N. Right. Right. The tricky bit of this question is what I'm about to do now. Is I am going to work out so if I want to work out M to N, this is the way I'm going to do it. I want to go from M to C and add on C to N. So this is where you should start writing things down. So the question says work out the vector M to N. M to N is M to C plus C to N. Okay, so that's how we're going to do that. M to C is easy because it's just A. So that's great. No problems with that. The challenge now is what C to N is as a vector. I'm going to tell you how to do this. There's no time to fully go through it. But first thing I'm going to do is I'm going to work out all of this vector c to b. But again, I can't do it directly, but I can do it the long way around. You see that I can go that way and then that way. So c to b is minus 2a against the arrows plus 3b. Okay, why did I do that? I did that because imagine you were traveling from C to B and it's in the ratio 3 to 2. Imagine it's a 5 mile journey, 3 and then 2. So it's 3 miles up to N and then another 2 miles up to B. If you go from C to N and I said to you, what fraction of your journey have you completed? Your answer should be 3/5 of the journey. The reason that is important is because since I know the vector for the whole journey, c to b, and I only want the vector c to n, I need to know what fraction c to n is compared to c to b, and that answer is 3/5. So c to n is 3/5 of c to b, which was minus 2a plus 3b. That's why I worked that out to start with. I worked out what all of it is, and then the fraction of it is the bit I want. If I expand the brackets now, unfortunately, vectors questions have loads of fractions. 3 times minus 2 is minus 6/5 A. 3 times 3 is 9/5 B. So that is the vector c to n, which will just go there. So minus 6 over 5A plus 9 over 5B. And then you simplify. 1A minus 6 over 5A is, oh God, minus a fifth A plus 9/5 B. That, incredibly, should be the answer to the question. I'm not looking at the mark schemes here. I'm assuming. I have confidence in myself. Use your answer to part A to explain why MN is not parallel to AB. Well, if that's the vector MN, AB is 3B. Okay, that's AB. There is no way of multiplying this by anything to get to there. Mainly because there's no A's in it, right? You can't conjure up the A's. So because it's only B's and that's A's and B's, um, they are not parallel. How you'd explain that? I don't know, but I'm telling you. That's what it is. Um, are these vectors related to the ones in science? You mean in physics, don't you? In physics, you get vectors in forces, don't you? Um, my answer to that question is going to be no, because you certainly don't get anything like this in physics. Yeah, I mean, you need to know that a vector is a potentially is direction related, but beyond that, no. So no. And lastly, we will do this. So C is the midpoint of the straight line. Remember, when you see midpoints in vectors questions, you should celebrate because it does make life much easier. The ratios are harder. Will we do science this week? Yes, we will. We are reverting to biology, but we've already started doing biology because it's the 1st October. The people in year 11 will be doing biology involving plant and animal hormones, majority of which involves the menstrual cycle. Is a big topic. And so 13C is the midpoint of the straight line AB. O to A is the vector A. O to B is the vector B. Work out O to C in terms of A and B. Well, C is the midpoint of AB. So if I could work out what AB is, oh God, what do I want? O to C. Right. O to C is going, the way I'm going to do it is I'm going to go from O to A and add on A to C. That'll get me from um, A to C. Right. Sorry, O to C. Now, O to A is easy because it's just A, but A to C is a problem because I don't know what this vector is. But what I'm going to have to do is work out what the vector A to B is, and then A to C is half of it because it's the midpoint. A to B is minus A plus B, which means that A to C is a half of all of that, which is minus a half A plus a half b. And then I'm going to take all of that and stick it there. 1a minus a half a is a half a, and then plus a half b gets you to the answer to that question. Hence, write down an expression for c to o in terms of a and b. Well, if o to c is this, c to o is just everything with a sign change, so minus a half a, minus a half b. Okay. Right, let me just I'm going to think about something. I can't immediately figure it out. Let me just see if I can. In fact, what I'll do is I'll just do something quickly. Sorry, I won't do this if it takes too long. Um, I think some missing information here. E to F is 2/5 of E to D. Okay, I think right. This is it's really horrible 7b, but I'll just tell you what the answer is. Um, it's to do with the fact that it's something. It's actually to do with the parallelogram because we haven't actually used that information yet. And it's similar triangles. God. So because of the parallel nature of all of this, it turns out, and this is why topics overlap a lot, this triangle here is actually similar to this triangle here. Similar means they have the same angles and they're just the same sort of ratios. So if this is, so you see this side here is 2/5 of all of that side there, because it's all of that, imagine that's 5, and then this is 2. So that's 2/5 of it, right? So that side there is 2/5 of the whole line. In the same way, this is 2/5 of all of that line because they are similar triangles. Again, this is not easy, but you're meant to deduce that E to F follows the same ratio as E to B and E to A. So E to F is actually 2/5 of E to D. And we worked out E to D in the previous question. So what you do is you do 2/5 of that answer. E to D is minus 5/3 A plus B. Is that the answer? I'm just making sure that is the answer. Uh, yeah, it was. And so if you expand this out, you get 2/5 E to D minus 10 over 15 A plus 2/5 B, which simplifies to minus 2/3 A plus 2/5 B. So that's a pretty hard question, but sometimes the really hard questions are worth quite small numbers of marks. In this case, 2, so it's not really that big a deal. Right, hopefully that was helpful. Next week, we'll talk about plant and animal hormones. If you have any questions,